Hello everyone. This video will go over an introduction to functions. Okay, so to kind of give you an idea of what we mean by function, let's go over a few terms. Okay, so let's say for example you have y equals 7x plus 2. Okay, so y equals 7x plus 2 actually shows the relation between x and y values. Okay, for example, if you make x equal 1, y would equal 9. Okay, so let's say, in other words, the relation is a set of ordered pairs. And the ordered pairs are your x comma y. Okay, so if we look at our y equals 7x plus 2, our relation would be 1, 9, or our ordered pair. So in other words, when x equals 1, y equals 9. Same thing if you have 0, 2. When x equals 0, then your y would equal 2. Okay? And of course, there are an infinite number of ordered pairs we could put up there, but those are just examples. All right. So that's kind of an idea of what the relation in ordered pair will look like. Okay. Now we're going to look at your domain of a function. And the domain is really just the set of all possible x values. Okay, and the range is the set of all possible y values. Okay, and those are only the values that correspond with the domain. Okay, so if an x value isn't in the domain, you can't have the range as part of that y value. So it corresponds to the domain. All right, so let's look at a few examples of your domain and range finding. Okay, so for example, let's say if we wanted to determine the domain and the range for, say for problem A, we have the points or the ordered pairs 2, 3, 2, 4, say 0, negative 1, just kind of change it up a little bit. And 3, negative 1. Okay, so that's the set of all of our ordered pairs. Okay, and they're kind of clustered together between these two braces. Let's say for problem B, we have the ordered pair negative 3, 1, -2, 1, 0, 1, 1, 1, and 2, 1. Remember, your ordered pair is x comma y. Okay. So your solution, and we're going to do problem A first. So if we're looking for the domain, remember that's all possible x values. Okay, so if we look just at our x values, that will be our domain. Now, even though 2 shows up more than once, you only have to write it one time. You don't have to write 2, 2, 0, 3. It's just 2, 0, 3. Or in most cases, they will put it in numerical order, which is 0, 2, 3. Same thing. Okay, now your range, remember your range, just all possible y values. Okay, so if we look at our y values, and I'll put the arrow up top for the y values, you have 3, 4, -1, and -1 for your y values. And again, even though the -1 shows up twice, you only have to put it once. Okay, so 3, 4, -1. Oh, let me write my brace a little bit neater here. There we go. Or, if you want to put it in numerical order, -1, 3, 4. Okay, so that's how you find your domain and range when your lineup of ordered pair look like that. Okay, so for problem B, I want you to write down the domain and range. Okay, so go ahead and press pause and solve that one. All right, so assuming you have already pressed pause and you have worked this one out, we're going to look at our domain. Remember, your domain, just all the possible x values. So you have -3, -2, 0, 1, and 2. Okay, so you have -3, -2, 0, 1, and 2. Now your range, remember that's just all your possible y values. So you have 1, 1, 1, 1, and 1. So even though it repeats over and over and over again, your range is simply the number 1. That's the only y value you have. It just repeats itself over and over and over again. Alright, so hopefully that made sense to you. Okay, so what if we kind of mixed up the look a little bit? Okay, so let's say, for example, we want to find the domain and the range for, and let's say on this side you have a list of cities, and this side you have the population in thousands. So our first city is Lubbock. Our second city is Colorado Springs. Okay, our third city is Omaha. And our fourth city is Sacramento. And this is what we call our input. Okay, so here you have 370,000. We're just going to put it as 370. You have 197,000. We'll just put it as 197. You have 404,000. We'll just put that as 404. Here we have 445,000. We'll just put that as 445. And let's say here we have 206. So this is what we will call our output. Okay, now they're not in order. So let's say Lubbock, we know that has 206,000. Okay, let's say Colorado Springs is 370,000. Say Omaha has 404,000. And Sacramento has 445,000. Okay, so how will we find our domain and range here? Put it right there. Okay, now remember your domain are all possible x values. In this case, your input kind of stands as your x values. And your output are your y values. Because you think about an equation, most of the time you replace x values. So if you plug in x, remember you have your x comma y. When you plug in x, what y value do you get? Here, when you plug in Lubbock, you get 206. That's your kind of your output or your y value. Okay, so your domain, and I'll put this underneath so we can get a little more room here. This is going to be a little lengthy. Okay, so our domain are all possible x values, which in this case would be Lubbock, Colorado Springs, Omaha, and Sacramento. Okay, so that's your domain. Now your range, remember that's all possible y values, or in this case your output, as long as they correspond to your x values, or in this case your input. Okay, so you have 370. If you notice, 197 does not have an x value going to it. So you don't write down 197 as one of our range values. Okay, so 370, 404, 445, don't write and 206. Okay, so quick note that the population of 197,000 does not correspond with a domain value or input. Well, to say domain entry instead of domain value, since these aren't values, but you get the idea, a domain entry. Alright, so now, since we have various ways of looking at the domain and range, we're going to look at the actual definition of a function. Alright. Okay, now a function, by definition, is a relation where every first value, or first component, and in most cases that's the x value of an ordered pair, corresponds to exactly one second component. That's the key phrase there, exactly one second component. And in most cases, that's the y value. Okay, so in other words, every x value has exactly one y value. Let me clean that up a little. There we go. Exactly. One y value. Okay, so let's see exactly how these function questions will look, or could look. Okay, so let's say, for example, you wanted to determine if the relation is a function. Okay, so for problem A, let's say if you have -2, 5. Let's say if you have 2, 7. Say you have -3, 5. And let's say if you have the ordered pair 9, 9. Okay, and let's say for problem B, you have the ordered pair -3, 2, 0, -2, 0, 3, say 1, 5, and you have 6, 6. Okay, so we want to determine if this relation is an ordered pair, or if this relation is an ordered pair. I mean, is a function. Sorry about that. Okay, so to find out if it's a function, first we're going to look at problem A. Okay, so we look at the x values. Here you have -2. -2 has a y value of 5. -2 does not have a different y value anywhere else. Okay, so -2 is good. Look at 2. 2 has a value of 7. 2 as an x value doesn't have a different y value anywhere else. Same with -3. -3 has a y value of 5. It doesn't have a different y value anywhere else. Look at 9. 9 has a value of 9. Doesn't have a difference. So it's actually a function. So it is a function since every x value has only one y value. Okay, so we know that A is a function. Okay. Now what about B? Okay, so if you look at B, you have -3 is an x value. So you have y value of 2 for -3. X is -3 doesn't have a different y value, so you're good there. You have 0 here. 0 is an x value, has a y value of -2. But if you look here, 0 as an x has an x value. 0 as an x value has a y value of 3. So 0 can't have a y value of -2 and of 3. So we know that B is not a function. Not a function, since x equals 0 has 2 different y values. Okay, so if we know that 0, -2, and 0, 3, this says when x equals 0, y equals -2. But this one says when x equals 0, y equals 3. Okay, you can't have x equals 0 for 2 different y values and call it a function. Okay, it goes against the actual definition of a function. All right, so hopefully that makes sense as to how you can see whether or not it's a function. Okay, so let's do a few more examples. All right, so let's say, for example, here, we want to determine if the relation is a function. Okay, so just like before, for problem A, we have the ordered pair 1, 1. We have 2, 2. We have -3, -3. And we have 0, 0. Okay, so for problem B, we have the ordered pair 11, 6. We have -1, -2. We have 0, 0. And we have -1, -1. And let's say for problem C, we have -4, 8. -2, 5. -1, 8. And 1, 4. Alright, so what I want you to do is I want you to press pause and determine whether A, B, and C are functions or not. So go ahead and press pause and work this one out yourself. Alright, so assuming you have already pressed pause and you have worked this one out on your own, we're going to go ahead and solve these. Okay, so if we look at problem A, you see that x equals 1 has only one y value. X equals 1 doesn't have a different y value anywhere else. Same with x equals 2, no different y values. Same with x equals -3, no different y values. Same with x equals 0, only one y value. Okay, so we know that A is a function, because every x has only one y value. Okay, so what about problem B? Okay, so if you look at 11, x equals 11, x equals 11 doesn't have a different y value. X equals -1 has a y value of -2, but if you look here, x equals -1 has a different y value. Okay, so x equals -1 can't have two different y values. Okay, so we know that b is not a function. Since x equals -1 has two different y values, and that's -1, -2, and -1, -1. Okay, so x equals -1 can't have two different y values. That's why that one's not a function. Now C, I put that one in there because if you notice, all of your x values have different y values. So -4 has a y value of 8. -2 has a y value of 5, doesn't appear anywhere else. -1 has a y value of 8. And x equals 1 has a y value of 4. Now if you notice, the y value 8 appears twice. It's still a function because even though an x value can have only one y value, a y value can have different x values. Because remember, the definition only says each x value has exactly one y value, not the other way around. Okay, so C can be a little bit tricky, but you have to remember each x can only have one y. Okay, so this one actually is a function. Since every x value has only one y value. Okay, so just for that type of problem, you want to remember that y values can have different x values and still be a function. Okay, so that was when we had the -4, 8 and -1, 8. Okay, these have the same y values, but that doesn't matter. Still a function. It's all about having the x values have only one y value. Okay, so hopefully that made sense. So let's move on to our next example. All right, so let's say if we want to determine if the following are functions. Okay, so let's say for problem A, we have A, B, C, D, and E. This is your input. And let's say for this one, you have red, blue, green, orange, and you have yellow. And this is your output. Okay, so let's say that A corresponds to green. You plug in A, you get green. Say B corresponds to red. Okay, plug in B, you get red. Okay, so let's say C corresponds to red also. Okay, let's say D corresponds to orange, and E, that goes to yellow. Okay, now for problem B, let's say if we have, say 1, 2, 3, 4, and that's your input. And let's say here you have A, B, C, and D. That's your output. Okay. Say that 1, we know that goes to B. And let's say we know 2 goes to B, 3 goes to B, and 4 goes to B. Excuse me. Okay, so we want to know if each one, if A is a function and if B is a function by definition. Okay, so if you look at A, notice that your input, which is considered like your X value, and your output here, that's considered your Y value. If you look at each X value has only one arrow coming out of it. So this X value has only one Y value. This X value has one Y value. This X value has one Y value. Now remember, you can have the same Y value as long as your X value has only one, even if that Y value is the same. So each X has one Y and each X has one Y. So as long as each input has only one arrow coming out of it, it's a function. Okay, so A is a function since every input for your X value has exactly one output. Okay, so hopefully that made sense. Okay, now look at B. Okay, if you follow the same logic, B is also a function because every input has exactly one output. Even though it's the same output, each input has exactly one. Okay, so it is a function since every input has exactly one output. Okay, so even though it looks a little bit different, the same logic applies. When you have your input and your output, that's your X and Y. The same rule applies as if you had ordered pairs. Nothing changes. Okay, so let's go to our next example. And let's see if this is a function. Okay, so let's say for your input here, you have A, B, C, D, and E. And let's say for this one, your output You have 1, 2, 3, 4, 5, and 6. Okay, so let's say that A corresponds to 1, B goes to 2, say C goes to 2, D, we'll let that go to 3, and 4, and we'll let E go to 5. Okay, so is this a function or not? Okay, so if you said not a function, you are correct. Okay, so it's not a function. Okay, now why is it not a function? It's not because of B and C, because B and C both go to 2, but that's okay. Because B only has one Y value and C only has one Y output value, Y value, whatever, however way you want to say it. So those two are good. It's actually because of D. You can't have an input with 2 outputs. So that's just like you can't have X equals 3 and X equals 4. You can't have D correspond to 3 and D corresponds to 4. So because you have 2 different arrows coming out of your input to 2 different outputs, that's why it's not a function. So it's not a function since the input D has more than one output. Okay, so hopefully that's making sense. All right. So now what if we looked at an equation and we wanted to find out if that equation was a function or not? Okay, so I'm going to show you I guess you could say the process of figuring it out, and then I'll show you a shortcut. All right, so let's see. To find out if an equation, remember this is just a linear equation, is a function. And make sure we're clear on the linear part because it differs when you get to quadratics and all that good stuff. So we want to solve for y to see if each x value has only one y value. Okay, so for example, let's say if you wanted to determine if y equals x squared is a function. Okay, so one way to see if it's a function or not, let's say if we let x equals 1. If you plug in x equals 1, that's 1 squared, so y would equal 1. So that gives you the ordered pair of 1, 1. Let's say if we let x equal negative 1. Negative 1 squared is just 1. Negative times negative is positive. So that's y equals 1. So that gives you the ordered pair, negative 1, 1. Okay, so let's say if we let x equals positive 2. 2 squared is 4. So that means y would equal 4. So you have the ordered pair 2, 4. Let's say if we let x equal negative 2. Negative 2 times negative 2 is positive 4. So again, we get y equals 4. So we have the ordered pair negative 2, 4. And it keeps on going like that when you let x equals 3 and -3, 4 and -4, all the way to infinity. Okay, so if you notice here, x equals 1 has only one y value. X equals -1 has one y value. Okay, if you plug in x equals -1 again, it won't give you a different y value. Okay, so this is actually a function because that will go for every value you plug in. Okay, so it is a function since every x value has one y value. Okay, some of the y values repeat. Remember, that's okay for functions. Okay, but you can only have, each x value can only have one y value. Okay, so what about if we wanted to determine if, let's say, x equals y squared is a function? Okay, now for this one, we're going to take a little bit of a different approach because we're going to plug in y values. Okay, so we let y equals -1. Okay, so -1 squared will give us 1. So that means x would equal 1. Okay, so remember, your ordered pair is x comma y, so that will be 1, -1. Okay, so what if we let y equals +1? Okay, when y equals +1, 1 squared is just 1, so x would equal 1. Now remember, our ordered pair is x comma y, so that would be 1, 1. Okay, so we can see there that the x equals y squared is not a function because you have x equal 1 giving you two different y values. X equals 1, y equals -1, or x equals 1, y can equal +1. Okay, so we know that x equals y squared is not a function. Not a function since you have x values with more than one y value. Okay, so this is the thought process behind it. Remember, I'm going to show you a shortcut, but I want you to get the general idea first. Okay, so let's say for our next example, if we wanted to determine if 3x squared plus y equals 1 is a function. Okay, so the first thing we want to do is we want to solve for y. So we subtract 3x squared from both sides. That gives you y equals -3x squared plus 1. Okay, so if you plug in x equals 1, you only get a one y value. If you plug in x equals 1 a second time, you won't get a different y value. If you plug in x equals 2, you won't get a different y value. Same with x equals 3, -3, 4, -4. You won't get a different y value for each one you plug in. Okay, so this one actually is a function since every x value has one y value. Okay? Okay, and remember, take a look at this because we're going to come back to the shortcut in a second. We'll come to the shortcut in a second. Okay, so what if you want to know is negative 3x minus y squared equals negative 1 a function? And if not, give an example. Okay, so let's say we want to solve for y first. Well, actually, we're going to solve for y squared. So we're going to add 3x to both sides. So that means we have negative y squared equals 3x minus 1. So instead of negative y squared, we're going to go ahead and divide each term by negative 1. So we have y squared equals negative 3x plus 1. Okay, now there's a reason we solve for y squared. Okay, so let's say if we let x equal negative 8. Okay, so if x equals negative 8, that means we end up with y squared, remember this is the one we're using, equals negative 3 times negative 8 plus 1. Okay, and of course this could work with any number of values. I just happen to pick this one because it helps reinforce the actual idea. Okay, so y squared equals negative 3 times negative 8 is positive 24 plus 1. Okay, so that means that y squared equals 25. Okay, so if we decided to make y equals positive 5, this would be true. Also, if we let 5 equals negative 5, this will be true because negative 5 times negative 5 is positive 25. I'm about to write 25 for some odd reason. Okay, so y equals 5 or y equals negative 5 can be true for x equals 8. So that means this could be x equals negative 8 can give you a y of 5, or x equals negative 8 can give you a y of negative 5. So you can see right here, you have two different y values for the same x value. So it's not a function. Okay, so x equals negative 8 has two different y values. And that's just one example. So not a function. Okay, now I'm going to show you that shortcut. If you notice, your functions all have y just to the first power, or no exponent, just y to the first power. This is a function because it's just y. This is not a function because it's y squared. And I'll show you when we get to our next group of examples why that is. If you look at this one, you have a y squared. You have a y squared here. Not a function. But if you look at the top one from this page, you have a y. It's not a y squared, so it's not a function. So whenever you see a y squared, you automatically know it's not going to be a function. Okay, so that's the little shortcut. All right. So now we are going to go to our next little section, which is our vertical line test. Okay, so that's a way to discover whether or not a function is, well, a graph is a function just by looking at it. Okay, so if no vertical line can be drawn, so that it intersects the graph more than once, then the graph is a function. Let me clean that up a little. There we go. And the graph is a function. All right. So in other words, all that says is if a vertical line crosses the graph more than once, it's not a function. If a vertical line crosses the graph more than once, the graph is not a function. Okay, so let's see exactly what we mean by that. Okay, so I'm just going to slide that up there. So let's say, for example, if we have our x and y axis, so we have our x and we have our y, and let's say if we have the graph, that really should be a straight line. It's kind of what happens when you eyeball it instead of drawing it with a straight edge. Okay, so let's say you have the graph y equals negative x, okay, which looks something like that. If you draw a straight line here, it only crosses the graph once. If you draw a vertical line here, it only crosses the graph once. If you draw a vertical line here, it only crosses once. If you draw a vertical line here, well, it doesn't matter where you draw a vertical line, you can never get the same vertical line to cross this graph more than once. No matter how far it goes this way or how far it goes that way, it would only cross it once. Okay, so you know that this is a function since each vertical line only crosses once. Crosses the graph once. Oh, sorry about that. Bring that up a little bit more. Okay, so we know that this is a function, y equals negative x, just by drawing it out. Okay, so let's say, for example, we have our x and y axis. So we have our x and we have our y. So what if we wanted to graph the line? Let's say this is 5 here. So we want to graph the line y equals 5. Okay. Remember, y equals any numerical value is just a horizontal line through that value. So y equals 3 would be a horizontal line through 3. Y equals negative 1 would be a horizontal line through negative 1. that's just how the y equals values will look. Okay, so if we want to determine if this is a function, do the vertical line test. If you draw a vertical line, it only crosses the graph once. We draw a vertical line here, it only crosses the graph once. We draw a vertical line here, it only crosses the graph one time. So we know that y equals 5, it is a function using the vertical line test because it only crosses the graph one time. Okay, we're not worried about this. This is your x-axis. We're just worried about our y equals 5. Okay, so hopefully that's making sense. Let's look at a few more examples. Okay, so if we go back to the beginning, we actually looked at x and y here. So the graph right here is actually the graph of y equals x squared. Okay, so if you do the vertical line test, here it only crosses once. Here it only crosses once. No matter where you draw a vertical line, it will only cross that graph one time. So we know that y equals x squared is a function. Well, we knew that already because this was one of our previous examples. But just looking at the picture, we can tell it's a function just using the vertical line test. All right, so let's look at another example where if we have our x and y axis, so we have our x and we have our y, but this one looks a little bit different, and this is actually the graph of x equals y squared, which was one of our previous examples also. Okay, so if you do the vertical line test here, if you draw a vertical line there, you notice it crosses that graph twice. If you draw a vertical line here, it crosses that graph twice. So if there's at least one place where drawing a vertical line will cross that graph more than once, it's not a function. Okay, so we know this is not a function using the vertical line test. Okay, so let's say if we get a little bit tricky here. Let's say if we have our x and y axis. We have our x and we have our y. Okay, and let's say if we decide to draw a vertical line through the x value 5, which of course is just x equals 5, when you draw a vertical line through a numerical value. Okay. This is actually not a function because this is your graph right here. If you draw a vertical line through this graph, you will actually go through each and every point of that graph. You only have to go through one point more than once, but if you draw a vertical line, you'll cross this graph at every point. Okay, so if we drew a vertical line, automatically, right there, we're crossing this graph in more than one spot. So we know this is not a function. Since x equals, and it's not just for 5, x equals any number, fails the vertical line test. Okay, so if you had x equals -3, it's just a vertical line through -3, it would fail the vertical line test. All right. So hopefully this is starting to make some sense. It's pretty clear. Okay, so let's look now at our next example which covers function notation. Okay, so function notation just lets us know that y is equal to f of x. Now this reads as a function of x, or most commonly f of x. Okay, so when you see this, you'll see, okay, f of x or function of x. Okay. All right, so technically all you are doing, let's say for example, if you have y equals 7x plus 5. If you wanted to write that as a function notation, it's just replacing the y with f of x equals 7x plus 5. Okay? Because we can see here that y is a function of x. If you replace x, y gets a different value. Okay, so all we did here was replace our y with f of x. Okay, so if you wanted to write this as an ordered pair, okay, so far our ordered pair, which is x comma y, becomes x comma f of x. Let me clean that up a little. Okay, so literally nothing else changes. You just replace y with f of x. All right, so let's go through a few examples of how to work with our function notation. All right, so let's say, for example, we want to find the value of each function. Okay, so let's say for problem A, if f of x equals 3x minus 2, we want to find f of 1 and f of 0. Okay, and let's say for problem B, if g of x, because remember that's just a variable, it could be g of x, f of x, r of x, it could be anything. It's the exact same way of doing it. Okay, so f, g, r, m of x, whatever, it's all the exact same step. Okay, so if you have 7x squared minus 3x plus 1, we want to find g of 1 and g of a. Okay, so these can mix it up a little bit. Okay, so let's say if we start with problem A. Okay, so f of x we know equals 3x minus 2. So to find f of 1, all that's telling us is that we're going to replace every x with 1. That's it. So that's going to equal 3 times 1 minus 2. 3 times 1 is 3. 3 minus 2 is 1. Okay, so that means that f of 1 is equal to 1. Okay, or if you wanted to write it as an ordered pair, when x is equal to 1, f of 1 is equal to 1. Okay, so what about our f of 0? And let me kind of separate that. So for f of 0, we just replace every x with 0. That's it. So that means we have 3 times 0 minus 2. 3 times 0 is 0, so 0 minus 2 equals negative 2. So that means f of 0 equals negative 2. Or if you wanted to write that as an ordered pair, when x is equal to 0, y is equal to negative 2. Or f of 0 equals negative 2. Because remember, this is written as x, f of x. When x is 1, f of 1 is 1. When x is 0, f of 0 is negative 2. It's the same as saying when x is 1, y is 1. When x is 0, y is 0. So if you replace that with y, it would be the exact same thing. But we're just writing it as function notation. Okay, so let's go ahead and do problem B, which is the exact same thing. Okay, so for problem B, we know that g of x is equal to 7x squared minus 3x plus 1. So if we want to find g of 1, what do? Exactly, we replace every x with 1. Okay, so we replace x with 1. So that's going to equal 7 times 1 squared minus 3 times 1 plus 1. All right. 7 times 1, well, 1 squared is 1 times 1, so that gives us 7 minus 3 plus 1, which is 5. So we see here that g of 1 equals 5. Or if you wanted to write that as an ordered pair, when x is equal to 1, g of 1 is equal to 5. Okay, so what about g of a? Okay, same thing here. You just replace every x with a. That's it. So that would be 7a squared minus 3a plus 1. I know you're thinking, it can't be that easy. Yep, it's that easy. And put that there. All right, so what if we have more than one term? Okay, so let's say, for example, let's say for the function, say n of y equals 4 times the absolute value of 3y minus 8 minus 4, we want to find n of y plus n of 1. Okay, so we're mixing it up a little bit, just a little bit. All right, so first, we want n of y plus n of 1. Well, we see here that n of y is just 4 times the absolute value of 3y minus 8 minus 4. Okay, so we have our n of y. Now we have to find our n of 1. Okay, so n of 1 is just 4. Remember, we just replace every y with 1. Okay, so we replace every y with 1. Let me move that over here just to... Okay, so 4 times the absolute value of 3 times 1 minus 8 minus 4. Okay, so that's going to equal 4. 3 times 1 is 3, so times the absolute value of 3 minus 8 minus 4. Okay, so that's 4 times the absolute value. 3 minus 8 is negative 5. The absolute value of negative 5 minus 4. Okay. Now the absolute value of negative 5 is 5. The absolute value of any negative number is just going to be a positive number. Okay, so that's 4 times 5 minus 4. So 4 times 5 is 20. 20 minus 4 is 16. So that means that n of 1 is equal to 16. Okay, so now we just add those two together. Move that up a little bit. So n of y plus n of 1, that becomes n of y is 4 times the absolute value of 3y minus 8 minus 4 plus n of 1, which is 16. Okay, so you can't do much with this one. The only thing you can do is combine these two like terms. Okay, so that will be 4 times the absolute value of 3y minus 8. Negative 4 plus 16 is positive 12, so that will be plus 12. And that would be your answer. All right. So let's say we go over one more example. Okay, so let's say, for example, let's say for the function, again, this time it will be capital F of x equals 2 times the absolute value of 5x minus 1 plus 2. What if we wanted to evaluate f of x plus 1? All right, so for this one, remember f of x plus 1, whatever's in there just means we're going to replace x with x plus 1. That's all that means. So that equals 2 times 5 times x plus 1. That x just becomes that x plus 1 now. Minus 1 plus 2. Okay, so the most we can really do is kind of simplify inside of here. So we have 2 times the absolute value of 5 times x, which is 5x. 5 times 1 plus 5 minus 1 plus 2. Okay, so if we go ahead and combine these two like terms, you have 2 times the absolute value of 5x. 5 minus 1 is 4, so it's plus 4 plus 2. And you can't really simplify this one any more than that. Okay, so that's your f of x plus 1. Alright, so hopefully this has made sense, and I will see you on the next video.